Hello everybody, welcome to a new lesson. So this lesson happens to be the final one for chapter 6. So as we get ready to close out the chapter, we want to review all the things we talked about. We'll practice this last section today. Tomorrow we'll work on reviewing everything and then get ready to test after that. So for today, we know in the past we learned how to graph our linear inequalities, our equations. This word inequality means not equal. So when you see this word inequality that makes it sound so complicated, it really just means we're talking about greater than or less than in our problems. Of course, we can have less than or equal to and greater than or equal to as well. So inequality means we're going to have either a greater than sign or a less than sign in our problems. In the past, we solved one of these at a time. Today, we're going to solve more than one inequality at the same time. So when we draw our picture, instead of just having one line, now we're going to have two. That's the big difference. So we know we talked about system of equations. So today we're talking about specifically for inequalities, meaning a greater than or less than sign. So let's look at a first example. So for 1a, we're asked to solve this system by graphing. So what you're going to want to have is these two equations. Now, when we go to generate our graphs, we know that we need to graph each line. So I'm going to draw a little sketch here, and we're going to have another graph come up in a second. But when we go to graph our lines, and this is where all of our skills from first semester come into play. If we pretend we're looking at this equation, and this was just y equals 2x plus 2, how would we graph that? Well, we know the 2 is our y-intercept. Because these are y, we want our equations written as y equals mx plus b, where b is our y-intercept. That's our intercept, where it crosses the y-axis. And our m, our slope, is here. That's the slope of our line. So the number next to x is our slope. The number added at the end is our y-intercept. So the y-intercept for this line is 2. So you could imagine you would go up 2 units, put a point there. Our slope, the m value, is also 2. So you could imagine you go up 2 and over 1. That's your slope of that line. Now when you go to draw the line, you have to think about what the arrow says. And we've done this already, but we know less than means you're going to shade below. And greater than means you're going to shade above, the opposite. And one other thing to think about is if you have an equal bar, your line will be solid. If you don't have an equal bar, your line will be dotted. So for this one, we're going to have a dotted line since it's just less than. So you could imagine you're sketching yourself a dotted line like this. And are we going to shade above or below the line? Well, less than says shade below. So we shade on the under part of this line. So this is the part of the line we would be shading. Everything below it here. Great, now let's look at the second line. So we can pretend this is y equals negative x minus 3. So my y-intercept is minus 3. That's where it crosses the y-axis. So I could go down 1, 2, 3. We're just doing this roughly as we practice this. We've done these lines before. And my slope is negative what? Well, you can imagine there's a 1 here. So my slope is actually, my m value is a negative 1 for this one. So from here, you could go down 1 and over 1. So your slope should look like that. Now, what kind of a line should we have? Is it dotted or solid? Well, there is an equal bar there, so this should be a solid line. So when we go to generate our line, it should be solid. Imagine that straight. And now, should we shade above or below? Well, greater than says shade above, so we'd be shading everywhere above our blue line. So what region of the graph is true then for both of these? We're looking at below the dotted line and above the solid line, or then our answer would be all of this in here. You can actually make that a different color just to emphasize that. So the green section in the graphs for all of our examples today is the part of the graph that is true for both of your equations. below the first line and above the second one. And here's that answer shown perfectly in our example. The first line here is dotted. We shaded below it. And the second line was solid, and we shaded above that. Which region of the graph is true for both of those? Just the green section here. That's the part that's below the dotted line and above the solid line, just the green. Now the yellow is only true for being below the dotted line. The blue is only true for being above the solid, so the only one that's true for both is the green. So for 1A, you're going to need to have yourself a picture like that. For each example that we're going to do today, you just need the equations, and then we're going to generate a picture for both of those and do a little bit of shading. So obviously, if you don't have colors in front of you, it's fine to just shade this part of the graph, this region of the graph. Just make it dark with your pencil. And that is it for 1A. So we're going to do the same kind of process as we work through these problems. So let's look at 1B. Which one of these pictures is going to be correct? So the first thing we want to do is make sure all of our equations are written in our slope-intercept form, which looks like this: y equals mx plus b. We've done that many, many times. So if we have that, and we know that is true, we want to rewrite both of these two equations in that y equals mx plus b form. So we have equation number 1 and equation number 2. If I rewrote equation number 1 in y equals mx plus b form, it would look like this. Y is greater than or equal to, and we should be writing this down, negative 2x plus 4. That's my first equation. If I rewrote my second equation in the correct form, I would have y is greater than negative 1/2 x minus 2. Now, how did I get this? Well, I had to subtract the x from both sides and then divide everything in half. If that doesn't make sense, just know that this is the correct form, and from these two things, now we can go ahead and draw our graphs. So we have one line that has a y-intercept of 4 and a slope of 2. Remember, our b value is our y-intercept, and our m value here is our slope. So y-intercept, it crosses the y-axis at 4. Do all of our graphs have a line that does that? 1, 2, 3, 4. Yep. That crosses at 4. They all cross at 4. So it looks like we have the same lines in all of our graphs. This one has a slope of negative 2. So they all have a slope of negative 2. But it says greater than here, so we should shade above the line. So if any of these are not shaded above the line, if there's just white space above it, we know it's wrong. So B is shaded below our solid line here, so that one's out. We can eliminate that. Now what else do we know? Our second line has an intercept of negative 2, so we see that. Negative 2, here and here, those are all true. But for this line, we want to shade above it. So let's check. Are any of our lines shaded below our dotted line? Well, we're looking at the bottom line here. Are any of them that are shaded below are wrong? So B is already wrong, we said. A shades below it as well, so that one's out. And looking at C and D, one of these has white space below it. And that looks like it is D that is shaded, or sorry, C is shaded below it. So C should be out as well. So if we look at what's what here, we shaded above the first line. So that would be true for this. And we shaded above our second line. That would also be true. So in the region that's true for both of those lines would be the green region we see here. It's the only part of the graph that is above both of the lines that we plotted there, above the first one and above the second one. So D should be our right answer, given that we're shading above both lines. Now the thing you need to make sure you get is that you're plotting. How do you plot your lines? If you can't do that yet still, you have to know this is our y-intercept. We use the letter B for that. The number next to x is our slope. That's our rise over our run. So over and over again, we're going to see that. For 1B, our answer should be D. So generate some kind of a picture like that. You don't have to use color coding. That's okay. Just go ahead and shade above both lines, and that's the region that is true for 1B. Okay, so 2A, we want to solve this system by graphing. So we're going to follow the same process. So this is our graph, and as you're starting to write that down, let me prove to you why that is the case. So if I take my pen, I'm looking at graph number 1. Y is greater than or equal to negative 3x plus 1. So this 1 is my b value, that's my y-intercept. So it should cross the y-axis at 1. So if I go up to 1, that will give me this point here. Next, I need to look at the slope. My slope here is a negative 3. We use the letter m to show a slope. So my rise over my run is negative 3. So I can rise negative 3. That means go down 1, 2, 3, and then go over 1. That will give us that point, and then we can draw our line. We know our line is solid because we have an equal bar, so solid line. Greater than tells us to shade above it. So we would shade above the line. That's how we got that whole blue section there. So that's the first line done. If we now look and focus our attention on the second line, we see y is less than or equal to negative 3x minus 2. Our b value is a negative 2. That's our y-intercept. So start at y, go down 1, 2. That gives us this point. Our slope is also a negative 3. So from here we could go down 3, 1, 2, 3, and over 1. That will give us this point, and then we could draw our line. Our sign tells us where to shade, so less than says shade below. So we would shade below this line. That will give us the whole yellow section that we see there. Now, the answer to the graph is always where the lines intersect and where they overlap in terms of the shading. So we have this whole blue region, this whole yellow region, but do they ever intersect? And the answer is no. So what do you say in terms of an answer? There's no solution because there's no region of the graph that is true for both of our greater than and less than signs. We have a blue region and a yellow region, but they never coincide. They never intersect. So the answer, in less words, you can just say is no solution. And make sure you have an image like this. You want to shade above this line and below the line on the left. You have a gap in the middle, and there's no solution. That is it for example 2A today. Great. So for 2B, if we were to solve this inequality by graphing, what is our solution? So first, as we're looking at this problem, let's double check how we got these lines. So we see greater than 4x. We can imagine that there's a plus 0 here. So our y-intercept for this first line is 0. So it's going to cross right at the origin. It has a slope of 4, so you can go up 4, 1, 2, 3, 4, and over 1. That would allow us to draw our graph like this. It's greater than, and there's no equal bar, so it should be a dotted line. And greater than says shade above it. So that's why we would shade this whole yellow region here. So that's all good. Our second line, it has a y-intercept of negative 3. So you can go down 1, 2, 3. That gives us this point. If you track the slope of 4, go up 1, 2, 3, 4, and over 1. That will give us that point. That's how you generate that line. It's less than, and there's no equal bar, so it should be dotted. And less than tells us to shade below, so we would shade underneath this line. That gives us this whole blue region here. So we know it's graphed correctly. Now the answer to the question, what is the solution to our system? Well, what region of the graph is true for this whole setup? Is there a part where the blue and the yellow intersect? Well, the answer must be then no. There's no part of our region that is true for the blue and the yellow, so there's no solution. Those inequalities never coincide. Great. So when you see problems like that, it's actually a lot shorter. 2B has no solution. They never overlap. All we're looking for today is overlapping with our regions. All right, so here's a problem with a little bit of context for us to think about. Don't worry about the words in the paragraph. We will get to the equations shortly. I'll expect you to write the equations and have a picture. So let's look at this. So we're talking about service. A college service organization requires that its members maintain at least a 3.0 grade point average. So this is something that is rather common for organizations in high school and in college. They expect you to maintain some sort of academic eligibility to be able to participate. They also want you to volunteer at least 10 hours a week. That's also common both in high school and in college. Specifically for college entrances, they want you to participate in a certain number of volunteer hours, showing that you care about the community. So we want to have a 3.0 grade point average and volunteer 10 hours a week. So those are two variables there. They ask us to define these and write a system of inequalities to represent the situation, and then give ourselves a picture. So two things we're looking at: 3.0 grade point average and 10 hours of volunteering a week. So let's use whatever letters we want. It's easy to use just the first letter of the word that is important. So we're talking about grade point average. So let us use G as our variable. So G is going to be grade point average. So it must be at least 3.0, so that means 3.0 or higher. So G can be greater than or equal to 3.0. That is our first equation. So have that part for your notes. Next, we know we need to have at least 10 volunteer hours. So V for volunteer hours is going to be our second variable. And at least 10 means it can be 10 or anything greater than 10. So we have V is greater than or equal to 10. That is our second equation. Now you can tell these equations are pretty short. So this is a problem that we can solve rather quickly when we get down to it. So if G is greater than or equal to 3 and V is greater than or equal to 10, what would our solution look like? Well, if we define our variables this way, our image would look like this. So we're going to have grade point average as our X. You see it goes from 0 to 4.0. Volunteer hours start at 0 and go up and up and up. We can stop it anywhere we want. Say we stop at 14 just for the sake of the problem. So our grade point average can be 3 or greater. So we would draw a vertical line at 3, and we're going to shade everywhere above it, greater than. So greater than means to the right for X. So we would shade that whole region, and let me do my pen, to the right. So this vertical line that you see here, this is G greater than or equal to 3. Now what about our second line? V is greater than or equal to 10. So for volunteer hours, we would do a horizontal line here. Greater than is going to be above it. So all of this. Now what region of the graph is true for both of those? Well, one was yellow, the other one was blue. When you combine yellow and blue, you get green. So the part of the graph that is true for both of those equations is this upper right portion here. That is where you have both a GPA that qualifies and you have a qualifying number of volunteer hours. So our graph should look something like that. You want to shade this little top corner there. If you have grade point average as your X axis and volunteer hours as your Y axis. So that's it for our picture. Now we can use that info to generate a point or two that we'll do on our next example here. Okay, so given that we have that graph, a college service organization requires that its members maintain at least a 3.0 and volunteer at least 10 hours a week. So they ask us now to name one possible solution. So you can name literally any combination of volunteer hours and grade point average that satisfies these requirements. So in other words, any GPA above 3.0 and any number of volunteer hours above 10 in unison will be true. So you can imagine any number of combinations of people. You could have somebody with a 4.0 that volunteered 10 hours a week. You could have somebody with a 3.2 that volunteered 20 hours a week. So there's an infinite number of possibilities. So you just name one. You can name anything that satisfies those requirements. So one of those possible answers you could say would be 3.5 GPA and 12 volunteer hours a week. Of course, that is true. But there are many, many, many types of combinations you could do here, as long as they satisfy those requirements of being higher than a 3.0 and greater than 10 for volunteer hours. So X value bigger than 3, Y value bigger than 10. If you have that, then it is a true solution. So you could use this one, but there are many, many, many others you could also use. So this is the extent of these inequality problems. We've graphed one before, so today was practicing graphing more than one, and then making sure we're looking at the region of the graph that is true for both of those as we graph those together.